page 711, and this is our refine lesson for, or refine session for lesson 32. And I thought I would just go ahead and read through these equations to help you set up your problems as you're working them on your own. So I'm going to start with the example here. It says Hala turns a jar lid 60 degrees. Then she turns it 225 more degrees. How many more degrees does Hala need to turn the lid to make one full turn? Now, what I like about these refined sessions is that it gives us a lot of detailed information, extra information on the side. So we have to remember for this equation that a full turn of a circle is 360 degrees. So you kind of have to start there. And this example shows us that if we add the 60 to the 225, and then we can set up our equation to have the 60 plus 225 is 285 plus some number equals 360. We've set up our equation, and then we know that we can simply subtract out the 285 from the 360 to get our answer. So you're going to go ahead and set up your subtraction problem right there and solve to get the solution to the example. Now this first apply it is a little tough, and this is why I wanted to make the video for you, because you have to be able to think in shapes and lines and remember the degree angles between straight lines and circles. So number one says, when the hands of a clock are on 12 and 4, they form a 120 degree angle. What angle is formed if the hands are on the 4 and the 6? Show your work. Well, this information right here really helps us solve this. And it says, I know the hands make a 180 degree angle when they are on 12 and 6. So we can kind of draw something out to help us with that. And I'm going to go ahead and draw a clock just for frame of reference. And I'm using actually my little sugar container in my kitchen to help me draw a nice little circle for you guys, just for the purposes of demonstrating. So I have my circle, and this is supposed to represent a clock. And we know that all clocks between 12 and 6 form a straight line. Therefore, this entire angle to this side, or this half, is going to measure 180 degrees. And so from 12 to 6 is a 180 degree measurement. But the actual problem is that, let's say, I'm not going to measure this perfectly, but let's say 4 o'clock is right here, and we know that 3 o'clock is at a 90 degree angle. 3 is right here. So the book gave us, I'm just going to pick a middle point. So the book tells us that, or this problem, between 12 and 4, we know that this is a 120 degree angle. So what we don't know is the rest of this between 4 and 6. But I know that the total is 180 degrees. So the way that I would set this up is, again, you can write two equations. 120 degrees plus some angle x equals 180, or 180 degrees minus the 120 degrees is the value of the unknown angle x. And I can tell by simply looking at that is going to be 60 degrees, because 180 minus 120 is 60 degrees. Oops, I forgot I'm not supposed to solve these for you guys. You're supposed to do them. Okay, so for number 2, Tyra's front door has a half circle window. What is the measure of the angle of the center piece of the glass? Show your work. Well, because again, this is a straight line, I know that the value of all of these angles is going to be 180 degrees. So you're going to want to start there, and you can add up these smaller pieces and subtract them from the 180 to get your leftover value. Number 3 says a windshield wiper turns through 140 degrees. The window cleaner sprays across 75 degrees. The wiper turns 40 degrees before it gets to the spray area. How many degrees past the sprayed area does the wiper turn? So this outside angle measurement, and it measures the whole 140 degrees. And we know that because this degree symbol's right here with the amount of degrees. And then we know that there's a spray area of 75 and that the wiper starts and turns 40 degrees before the spray area, so the leftover amount is what we have over here. So essentially what we're doing is we're gonna set it up. We know our total is 140 degrees, and then you can subtract out each of these to get your leftover amount of degrees, or you can add them together and then subtract them. So we have 140 degrees total, and I'm going to do minus the sprayed area minus the wiper start. Or you could do the sprayed area plus the wiper start plus some unknown value is the total area. And again, we're trying to find this leftover area over here. So number 4 says, Keith uses a can opener. Each time he twists the knob on the opener moves 36 degrees around the lid, which best describes how open the can is after 5 twists. Well, if we know that each twist is 36 degrees, this is simply a multiplication problem. So you're going to multiply the 36 degrees times the 5 total turns, and you're going to get one of these answers. So it says, which best describes how open the can is after 5 turns. So how many total open? Is it 1/10 open, 1/5 open, half open, or completely open? And just remember, that's 360 degrees around a full circle. So whatever your answer is, its relation to 360 degrees is going to be your answer. Number 5, a tire swing hangs straight down. A child gets on the swing, swings forward 50 degrees, and swings back 95 degrees. How many degrees forward must the swing go to return to its starting position? So once back, where does it go from here? So if I know the total is 95 and we go forward 50, this is a subtraction problem. So we do the 95 degrees minus the 50 degrees to get you this amount that's over here. And just recall, whenever you see a line that goes across both angles with a degree measurement, that means the measurement of the entire degree. And we see we only have one part, so we have to find this other part. Number 6, tell whether there is an angle of each given measure shown in the diagram. So it says, is there an angle of 225? My recommendation is to add up certain parts and see what those parts equal. For example, what would the 160 plus 40 equal? Or the 160 and 40 and 65 equal? 160, 40, 65, and 25 equal. And then just kind of try and find the little parts that are shown here. Number 7, the measure of one angle is given in the figure below. So we have 110 degrees. This total angle of this measurement right here is 110. Use a protractor to measure angle A. Without measuring angle B, what is the measure of angle B? Okay, so I have to find this small angle right here, and I'm going to go ahead and, let's see if I can do that. I need to lengthen out my line. I like it to go straight through my protractor. So I'm going to lengthen out this line. Now, let's talk about what we can already tell regarding this angle. So I can tell it opens to the left, so I'm going to have to use the outside numbers on my protractor. I can also tell that this is an acute angle. It is smaller than 90 degrees. So that's how I'll know whether or not I'm getting close on my measurement. So I'm using the protractor to measure angle A, and I see that that line goes straight through the 40 degrees. So now I know the measure of angle A is 40 degrees. So now how do I solve for B without actually measuring it in my protractor? And the way you solve is you can do 110, the total value, minus the measurement that we measured, 40 degrees, is some degree And that's what you're going to solve for.